Hello, today I am going to show you on how to find an unknown side or an unknown angle in a right triangle using trigonometry. There are two questions that you want to ask yourselves. First one is, what are you given? Are you given one side and one angle of this right triangle, or are you given two sides of the right triangle? This is what you're given, and then what are you asked to find? Are you asked to find the other leg of the right triangle, or are you asked to find the unknown angle that is not the right angle? Based off on these two informations of questions, then you can decide which process that you want to continue to use. All right, let's review three basic trigonometric identities: sine, cosine, tangent, sine of an angle that is not the 90-degree angle. Theta is equal to the opposite side of theta over the hypotenuse. The cosine ratio, the cosine of angle theta equals the adjacent side of theta over hypotenuse, and the tangent of angle theta is equal to the opposite side over the adjacent side. Alright, so here we want to label of what we know. First thing that we do know is the hypotenuse. Not because it is a slanted leg, but it's because it is opposite to the 90 degree. If angle theta was right here, then this is set to be the opposite side, and this is the adjacent side. In example 1, we are asked to find the missing side of the triangle, and we're going to round to the nearest tenth if necessary. So you want to ask yourself, what are you given? Are you given two of the three sides, or are you given one side and one angle? And by given, I mean numerical values. Here's a numerical value that's given. This is our angle. Here's another numerical value that we're given. This is the opposite. Here's my 90 degree. Here's my hypotenuse. And here's my adjacent. So I'm given an angle, an adjacent, and my asked to find the hypotenuse. So I am pretty much using adjacent and hypotenuse. So which trig ratio am I going to use? Right. Adjacent, this one does not have adjacent, this is for sine. For tangent, it does have adjacent, it does not have the hypotenuse, so I'm not using this one, so I'm using cosine. So cosine of 37 degrees equals adjacent, which is 8, over the hypotenuse, which is x. This over 1, so we can have a better understanding of the cross multiplication. X times cosine of 37 degrees is x times cosine of 37 degrees equals 1 times 8 is 8. A lot of teachers will say just put in cosine of 37 degrees in the calculator so it's easier to understand of what you're doing afterwards. I would agree in that sense. Because this is what cosine of 37 degrees approximates to. That is equal to 8. It's easier to see in this step than this step in terms of what do you need to do in order to solve for x. And by easier, I mean for most students. A lot of students have a difficulty of understanding this multiplication, and you need to divide both sides by cosine of 37 degrees. Once you do this, we get that x equals 10.017 and so on, right? But it's asking us to find the side to the nearest tenth if necessary. That's the reason I didn't go anywhere further, because x equals to 10.0 after rounding off. We are asked to find the missing side of the triangle around to the nearest tenth if necessary. Again, for the second example. Again, are you given two sides or are you given one angle and one side? Here I'm giving angle at 73 degrees. This is my opposite. This is my hypotenuse, because it is opposite from 9 degrees. For hypotenuse, here's my given angle. This is my opposite side of angle theta. This is my adjacent side. So I'm using opposite and adjacent. Opposite and hypotenuse, that's not what I'm going to end up using. Cosine is adjacent over hypotenuse. I am using adjacent but not hypotenuse. Tangent is equal to opposite over adjacent, so I'm going to end up using tangent. So to get this started, tangent of angle 73 degrees equals opposite, which is x, adjacent, which is 15. Set this over 1 so we can see the cross multiplication happening. This is 15 times the tangent of 73 degrees is equal to 1 times x is x. There's no need for me to divide anymore. I'm just going to end up using this in the calculator because it's already solved for x. And we get that x equals 49.062. I'm running to the nearest tenth, so x equals 49.1. Here's my tenths place. Look at the next side. Yes, a 6 is bigger than 5. That's why the 0 rounded into a 1. Example 3, I am asked to find the missing side of the triangle and round to the nearest tenth if necessary. So here's my angle. Here is opposite. And here is hypotenuse. Here is adjacent. Opposite and hypotenuse is sine. So I'm using sine of 65 degrees equals x over 6. Set this over 1 so the cross multiplication is easier to see. 6 times the sine of 65 degrees equals 1 times x is just x. 6 times the sine of 65 degrees in the calculator is 5.437. So it approximates to 5.4. In example 4, we are asked to find the missing angle of the triangle and round to the nearest tenth if necessary. Now, if you jump through the actual questioning, again, two questions you want to ask yourself. Are you given two sides or are you given one side and one angle? All right, here is the angle. Here is the opposite. And here's my right angle. Across from it is my hypotenuse. So I do not know the angle. I am giving an opposite and a hypotenuse, two of the three sides. All right, and I'm trying to find an angle that is not the 90-degree angle. This one right here. All right, so to set that up, again, we're going to start as well. Am I going to use sine, cosine, or tangent. I'm not using any adjacents, so I'm going to be using sine. So to set this up, sine of angle theta equals opposite, which is 8, over the hypotenuse, which is 10. Alright, this is slightly different in terms of solving for the angle theta. Alright, the only way to undo a sine is to do some call this arc sine, which is sine to the power of -1 of this angle right here. Again, some call it arc sine, some call it inverse sine. Whatever you do to the left side, you also have to do to the right side of the equation. When you do this, the arc sine or inverse sine and sine reduce each other out, and all that's left is the angle itself. Angle theta equals the inverse sine, or the arc sine, of 8 over 10. Or if you want to use 4 over 5 by reducing the fraction, that's fine. Again, you have to do this in your calculator. Make sure that your calculator is also in degrees. Once you put that in your calculator, you get that theta equals 53.13, and so on the calculator, but I don't care about the rest of the decimal because I'm running to the nearest tenth. So theta is going to equal to 53.1 degrees. Here in example 5, I am asked to find the missing angle of the triangle and round to the nearest tenth if necessary. Again, same questions. I am given 2 of the 3 sides and I am asked to find an angle. Right? I'm not giving an angle. Right? So which trig ratio am I going to use? Am I going to use sine, cosine, or tangent? Here's opposite, here's hypotenuse, and here's adjacent. I'm not given hypotenuse, so I'm going to eliminate everything about hypotenuse, so I'm using tangent. Tangent of angle theta equals opposite, which is 15 over 49. Again, to get rid of tangent, I'm not going to use the inverse sine. I'm using the inverse of this here, or the arc of this here, which is that there. Alright, the inverse tangent or the arc tangent and the tangent reduce each other off, and I'm left with angle theta equals the inverse tangent of 15 over 49. Again, you need your calculator for this. Do not forget to be in degree mode. So tangent equals 17.020. Since I am asked to round to the nearest tenth, you get that it's rounded to 17.0 degrees. Last example. Again, find missing side. Since I'm missing side, I'm given 2 sides. Here's my angle, here's my opposite, here's my right angle, here's my hypotenuse, and then here is my adjacent. So which am I going to use? Sine, cosine, or tangent? I'll give you a little time to figure that out. Okay. I am not using opposites, so everything with opposites are canceled out, and I'm left with cosine. Cosine of angle theta equals adjacent, which is 5.4, over the hypotenuse 6. For this part here, again, since we are dealing with cosine, we are taking the arc cosine to both sides. I've been showing to the power of -1. This is another way of how you can write your work in paper. Arc cosine this arc cosine and cosine reduce each other out, and again we're left with theta equals alright, you are not going to see this very frequently. It's very rare that you see it. It used to be done, but no longer it is used, specifically because of our calculators not seeing this button or command in it. Alright, that's the reason why it has transferred over into this labeling, because this feature is in the calculator. Once you do this in the calculator, we get that theta equals 25.841, which means that theta is about 25.8 degrees.